Hey, folks, I know that getting a test back is an emotional experience, right? You see a score at the top of your paper, and you can very easily shift over into a fixed mindset. I can't do it. I'm not smart enough. My teacher's not good enough. I don't have enough time. I can't find the motivation. You can come up with all those different reasons, and all those reasons, I think, kind of push us into that fixed mindset. Like I was born with a certain amount of intelligence, and I can't figure this stuff out. So I know that is not true. I know you can figure it out. I know you can do this stuff, and I want to help you. I don't want this to be difficult. I want it to be as easy as possible, but it does require some work and some commitment. And I really appreciate you guys doing that, making a commitment and or recommitting. Maybe you kind of lost your motivation there for a while. It's not too late. This is a long year. It's like the old saying, it's a marathon, not a sprint. Okay, so we can do it. We can make some fixes. We can correct some tests and raise our scores, and you'll be all right. Okay. So, anyways, on problem number one, here's what I want you to add to your work is put a little drawing down, and you don't have to complete the polygon. You can just make a few sides, and even if you think, well, there's no way this is a pentagon, it doesn't matter. It's just for our brain to look at what an exterior angle looks like. An exterior angle is right there. And so the exterior angles, if you drew one at every single vertex in every single polygon, I know this is a shocking fact, come up to 360 degrees. It's a really simple idea. I didn't do a proof of it. I'm not going to do a proof of it right now, but that's the sum of all exterior angles. Sum of exterior angles. Okay. All right. So, well, then what do we do with that? Well, if there are five of them, because we have a pentagon means you got a five-sided figure. If there were five of them going around, well, I just divide by five, and then I would get the one exterior angle. So let's see, how many times does five go into 36? Goes into there seven times. Can you imagine that? 7 times 5 is 35. You take your one because we came up to 35, we're one short of 36. Take your one over to the zero, make it 10. How many times does 5 go into 10? 2 times. Or you just punch it into Desmos or your favorite calculator. Okay, so 72 degrees for the exterior angle. If the exterior angle is 72 degrees, then the interior angle is 180 minus 72, because we need these two to add up to be 180, right? So we end up with 108 for the interior angle. So this one is 108. See, I would like to see some work over there. Now, people did it differently. Some people did n minus 2 times 180. That's the sum of the interior angles. That would be like all the interior angles in here added up, right? So if I put double tick marks on the interior angles, all right, that would be the sum of all of them. But you'd have to plug a 5 in here, in for n, because you have 5 sides, and then you would divide that by 5. Well, this number right here, it gets bigger, than this 360 number, because 3 times 180 is 540, 540 divided by 5. So the arithmetic just gets a little bit unwieldy if you have like an octagon or a 20-sided figure. I think the arithmetic finding the exterior angle first is a little bit easier. So let me just say it again. I got 108 for the interior angle. You get 108 doing it this way also, because 540 divided by 5 gives you 108. Okay, so that's another way of doing it. If you do that work on the hexagon and the octagon, let's just finish this idea off right here. Well, if it was a hexagon, I'm going to divide by 6. So let's divide 360 by 6, and I get 60 degrees. So if the exterior angle is 60, the interior angle is 120. So the hexagon is 120. If I divided 360 by 8, 8 goes into 360 45 times. Okay, so if we had an octagon right down here, 8. Okay, this was the hexagon I did a second ago to get 120. Now I get 45 degrees. Okay, so if this was 45 on the exterior angle, the interior angle is 135. So 135 degrees for the interior angle. So it wanted the interior angle, and it says it's a regular polygon. So that's really important. Regular means all of them are equal, all the angles, all the sides. Okay. Hey, look, we got a pentagon. What did we just say about a pentagon? 108 degrees? No, we can't use that information because it's not a regular pentagon, right? But we can use the 540 degree information. So the sum of the angles on the interior are 540 degrees for this pentagon. We just used up 90, 90, 90. That is 270 degrees. So I'm going to subtract 270 degrees from that 540, and I get 270. Oh, that's kind of weird. There's 270 left for this angle plus that angle up there. All right, so let's think through that again. How did I do that? I had 1, 2, 3, 4, 5 sides. I used up 90, 90, that's 180, plus 90 more is 270. So if I take 270 away from 540, I got 270 between these two angles. So I go 6x plus 1 plus 8x minus 11 equals 270. I get 14x minus 10 equals 270. I add 10, I get 14x equals 280. I divide by 14 and I get 20. Okay, my x is 20. Is that what they're looking for? Nope. They're looking for angle C. So I got to take 20 and put it in right here. So angle C, the measure of angle C, is equal to 8 times 20 minus 11. That's 160 minus 11. I think that comes out to be 149. So this is 149 degrees here. Boy, I hope I don't make an arithmetic mistake. Let's look at the next bunch. Boy, this is going to take me a little while to get through all 10 of them. If you had a parallelogram and W was 38 degrees, so on your page of work, I gave you a drawing of a parallelogram. And so I would find the acute angle and I'd put 38 degrees just so my brain isn't like freaking out. I wouldn't put 38 up here, I'd put 38 down there. And I would call it angle W, okay? Now, when they go W, X, Y, Z, when they list out the letters like this, you could go W, X, Y, Z, or you could go W, X, Y, Z. What you cannot do is go like this, W, X, Y, Z. That's not okay. You got to just go around the figure. So W, X, Y, Z. I'm going clockwise around the figure. You could go counterclockwise around the figure. Doesn't matter. But the deal is consecutive angles are supplementary. So if we had 180 to use between these two angles and I take 38 away, this is going to be 142 degrees. So let's see, angle Z. Oh, wait, they're looking for angle Z. Doggone it. Well, 142 would be over here also because the opposite angles are congruent or the consecutive angles are supplementary. So I put 142 degrees right there. Parallelogram EFGH. Here it is right down here. And it says, how big is angle E? So angle E is the same size as angle G. But we need to first figure out how big G is. Well, these two angles are supplementary. They add up to be 180 degrees, consecutive angles, because they're between parallel sides. They're called same side interior angles or consecutive angles in the parallelogram. So you go 3x minus 15 plus 7x minus 5 is equal to 180. See, if people put down that these two angles are equal to each other, that was a bit of a desperation move. I can understand why you would do that. Like you're nervous and you're like, hey, I don't know. I'm just going to set them equal to each other. And you did some great algebra. You found out what X was, but you're not finding the correct X. The correct X would be if you added them together and set equal to 180. So that setting up the equation part the wrong way resulted in a 2 out of 6. Because I mean, you did something. You did some algebra, but it wasn't going in the right direction. We want to practice deductive reasoning skills, which means you look at the given figure and you say, hey, what can I conclude about this figure? It's got parallel, opposite sides parallel. It's got consecutive angle supplementary. So then you do the rest of the algebra. 10x minus 20 equals 180. I moved the 20. I got 200. So 10x equals 200. X is equal to 20. I plug 20 in right there. So 7 times 20 minus 5. So the measure of angle G is equal to 7 times 20 minus 5. That's 140 minus 5 is 135. So angle E is also 135. Do you see? I mean, that's not an easy problem. Don't beat yourself up if you're missing some of this. But I tell you what, you got to practice, right? I mean, I don't think anybody could just come into this test cold, not doing a single homework problem, not spending any time in class, not listening to any videos or any direct instruction or working with a partner, and just nail this test. That's just, I don't think that's possible. FG, where is FG? They also want us to find FG, right? So they want us to find this side right here. Okay. So this piece of information right here is going to be used after we find out what y is. So I'm going to set y plus 8 equal to 3y. Y plus 8 equals 3y. I subtract y from both sides, and I've got 2y equals 8. Y equals 4. Okay. I take the 4 and I plug it right there. So if I put 4 in there, 2 times 4 is 8 plus 1 is, oh man, hold on one second. I didn't pay attention to those parentheses. I got to add 1 to the 4. I get 5 plus 2 is, or times 2 is 10. This side over here is 10. So is this side right over here, 10 also. Okay. So how did I do that again? I went 2 times the quantity, 4 plus 1, which is 2 times 5, which comes out to be 10. All right. Number 5. Here we go. Number 5. Let's see. We got a parallelogram, and it says, what are the coordinates of point H? Now, I liked what I saw. A lot of people said, hey, I did this one on GeoGebra, and I saw somebody just try to graph the points. Okay, so let me try that technique here real quick. If I went over 1 and I went up 3, 1, 2, 3, we want to make this look somewhat accurate. We go over 3, so here's 2, here's 3, and I go up 5, so I got to go up 2 more. There's 5. Okay, so here's 3, 5 right up there. Maybe I'll list. Oh, geez, that point's in the wrong spot. I want it more like there. 3, 5. Okay, and then I got another point at 4, 2. So let's go over one more to 4, and let's go to 2. So here's 4, 2 right there. 4, comma 2. And let's label the points. So we had E here at 1, 3, okay? And then we had F, and then we have G, and then we're looking for H. So when you do this, you got to go E to F, F to G, G to H, because look at the order the letters are in, okay? We got to just continue to go in the correct order. So here's what I need to do. How do I go from F to E? I go down 2, I'm going down 2, and I'm going over 2, okay? So this one has to do the same thing. Go down 2 and over 2, and there's my spot right there at 2, comma 0. All right, that's where H is located. And I don't know, were those the same numbers as what was on the practice test? It might have been. It looks really familiar from the practice test. Let's see. So 2, 0, this is a printout. You had a place where you could choose 2 and 0. Anyways, one pair of base angles of an isosceles trapezoid. Well, let's make an isosceles trapezoid. And so that means we got a trapezoid with equal sides. And it says one of the base angles, or one pair of base angles of an isosceles trapezoid, each have a measure of 2 times the quantity x minus 10. 2 times the quantity x minus 10. And says the other pair of base angles in the trapezoid have a measure of 4x plus 8. So I'm going to put 4x plus 8 up here. Now, I did put 4x plus 8 on the obtuse angle and 2 times the quantity x minus 10 on the acute one. That was just by chance. Doesn't matter. I mean, if it's off, if I have them backward, I'm not going to pay any attention to that. All I care about is that I've got them on the base angles. Well, these two angles are supplementary. They add up to be 180 degrees. So I'm going to do that right now. Set it equal to 180. I'm going to distribute the 2 through 2x minus 20. I've got an 8. I've got 4x. I add those two together, I get 6x. I add these two together, I get negative 12. That's equal to 180. I move the 12 to the other side. I got 192. 6x, 6 goes into 192, 32 times. Whew, my x is 32. Is that what they're looking for? Yes, they are. Good, I'm done. I don't have to plug it back in. Trapezoid PQRS has vertices 0, 0, 0, 4, 6, 4, and 12, 0. What is the length of the mid-segment? All right, again, I saw a lot of people do this on GeoGebra. You put a dot at 0, 0. You put one at 0, 4. Here's 0, 4. You put one out here at 6, 4. Let's see here. Let's say this is 6 and this is 4. There's 6, 4. And then you put one out here at 12.0. So let's put this guy at 12.0. Okay. So there, that base right there is 12 long. This base up here is 4 long. The mid segment right in the middle, I know I haven't made the other side of my trapezoid. This mid segment is the average of these two. What's the average of 4 and 12? Well, I add those two together, 4 and 12, and I divide by 2. So I get 16 divided by 2 is 8. So the mid segment is 8 long. Fill in the blanks using the available answer choices in a regular 10-sided polygon. Each interior angle is. So you know my technique. I like to go 360 divided by 10 because this is going to get me one exterior angle. 36 degrees is the exterior angle. Now I take 180 minus the 36. That's going to give me 144 for the interior angle. Okay. The measure of each interior angle is 144. Oh, this one, look, we just figured that out. A tengon, a 10-sided figure, a decagon has 144 degrees. So 10 sides. I saw some people put their work down like this. Look up above. We just did that one. In the kite, okay, then I gave you a drawing of a kite. And I didn't mark which two sides are equal, which threw some people off. You know, these two sides look equal. I know we're not supposed to go by what it looks like, but we're just using the drawing. Now we're claiming that these two sides are equal and these two sides are equal. Well, the angles that are between the equal sides are the ones that are different measure lengths. The ones that are between the two different side lengths are equal to each other in a kite. So these two are equal. These two are not equal to each other. So this angle up here, I thought in my drawing looks like 90 degrees. The angle down here looked smaller than this one. So I'm going to call this one 36 degrees. Okay, so 36 and 90 makes 126 degrees. How many degrees do we have to use in a quadrilateral? 360. So if I subtract those two, I think I end up with 234. So 234 divided by 2, because each one of these is equal to each other. So I'm going to take 234 divided by 2, and that comes out to be 117 degrees. Ladies and gentlemen, this is not an easy test. Don't beat yourself up. Give yourself a chance. Do the homework every night. You know, I want you to spend about a half an hour on homework every night. Watch my videos. Take good notes. Ask me questions about the homework problems. If you're doing all of those things, you're in the growth mindset camp. Growth mindset people believe through hard work, I'm going to get smarter. Fixed mindset people look at obstacles and they erect obstacles for themselves. Like, I can't do this because, my last year's math teacher was terrible, or I can't do this because I'm not smart enough. You can do it. Okay. I know you can. I just want to help you. I don't want this to be too difficult. Thanks for your effort.